In this video we're going to talk about solving an inverse trig equation exactly. We're working with inverse tangent, inverse cosine, inverse sine, different ones. Okay, so we'll do a couple of these and leave the rest of them for you to practice. Okay, so for this first one we have -4 arctangent of x equals pi over 4. Right, so if we divide by 4 to both sides, we have that the arctangent of x is equal to pi over 4, right? And now we can think about this as, hey, what angle, right? What angle, what is the ratio when the angle is pi over 4, right? That we can come over here and we can say, hey, x is going to be, right, the tangent of pi over 4, right? That we can undo the arctangent by taking the tangent, take the tangent of both sides, and really this should be a negative pi over 4. I missed a negative sign there, right? So x is the arctangent of negative pi over 4. From our reference sheet, from the unit circle, or our knowledge, we know that that is -1. Okay? We'll let you work B and C on your own. Right? We'll look at D over here. Right? Notice that this notation with that superscript -1 is another way of saying inverse. Right? So we can say inverse with this ARC preceding our trig function, or with this superscript of -1. So in this situation we have 5 times the inverse sine of some angle minus 2 pi equals 2 times the inverse sine of that same angle, minus 3 pi. This angle and this angle must match. Right? So if I move things around, I'm going to subtract from both sides here. Right? Subtract from both sides. And I will have there that 3 times the inverse sine of some angle x plus pi minus 2 pi is equal to -3 pi. Right? Add 2 pi to both sides. 3 inverse sine of x plus pi is equal to -pi. Divide both sides by 3. Inverse sine of x plus 4 is equal to -pi over 3. Right? And I want to be showing each of these pieces. And once again, remember that when it says exact solution, the implication is that you need to show all your work as if you didn't have a calculator. Of course, you'll be able to use a calculator to check your work. Okay? So here, undo the inverse sine by taking the sine of both sides. Right? So I'm going to have x plus 4 is equal to the sine of -pi over 3. So that means that x plus 4 is going to be equal to -√3 over 2. So x is going to be -√3 over 2 minus 4. That is my exact solution. If I wanted to check my work, right, second plus 712 to clear out my calculator. Okay, and I could just double check that this answer does work within this piece, right? So I could go second quit, right? And I could come over here and graph 5 inverse sine of x plus pi and minus 2 pi. I missed that at the end. And graph the next equation. Alright, so I've got my two equations in. If I go to zoom 0, right, it'll look to fit my graphs where they most likely intersect, right? And I can see right down here that they intersect. Okay. Of course, I could also just do zoom 6, which is my standard zoom. Right, and the only thing about that is I may not see everything. Notice the intersection seems to be a bit below, so I can adjust my window. Right, it doesn't seem like I need to look all the way to x max of 10. It seems like it's in the negative x's. The y minimum does seem like it needs to be a lot less. The y max can be 0. It looks like I'm only looking in that third quadrant. Right, and so there I have one graph, another graph. Second, calculate intersection, right? And I can arrow, right, close to my point of intersection, right? And if I arrow up or down, notice how my function is changing, right? And arrow left or right close to the point of intersection, hit enter 3 times, and it gives me my intersection, which is at x is negative 4.007618, y is negative 11.51917, right? So I can check out that information fairly readily. Okay. Now, of course, if I'm looking at this, realize that I actually read this information wrong. Hey, here is a pi. All of a sudden, it changed to a 4. Right? That this value here should have stayed as a pi, that value should have stayed as a pi, that should have stayed as a pi, that should have stayed as a pi, and so this answer here should have stayed as a pi. Right? What lets me know I probably made a mistake? Well, negative 4, right, would have been not the same as negative root 3 over 2 minus 4, right? And so I can double check that that negative 4.007618 is the same as this value, right? One thing I can do is hit store, right? And I can say, whoops, second quit. I can store that answer I got into letter A, right? And that's the answer I had. And then I can just double check, is negative root 3 over 2 minus 4 the same as that value? No, it's not the same. But is negative root 3 over 2 minus pi the same? Yes, it is, right? And so do be careful when you are working through that you're thinking about your work and you don't make those careless mistakes of changing a number, right? Because you weren't being careful in your work, right? That I started out with pi, and so each time it should have stayed as pi. That's the types of mistakes that I've seen students make, and that's why I bring them up, right? But we also talk about how you can check your answers. Here's my exact solution. This is what I would do if it says find the exact solution. If it simply said use my calculator to find the solution, right, and I could have given you the graphs to make sure that you have the right graphs, right, well, I would just go to that graph, second, calculate the intersection, right, arrow near the point of intersection, press enter 3 times, and I have my answer. All right. Make sure you're getting your practice in. Ask questions for clarification where needed.